So what are some issues regarding the waste? Okay, so at an aluminium plant, exhaust gases are a major problem. Okay, so we emit mostly HF, CO2, and SO2. So this is a contributor to acid rain, sulfur dioxide. This one here is the global warming gas. For those who think climate change is caused by humankind, this is a major contributor of that. And this one, HF, is a very, very toxic chemical called this is basically hydrogen fluoride. It's used in the solar cell manufacturing process as well. But essentially what it does is it's extremely poisonous, and even if a small amount gets into your body, it can cause death. So this is not something that we want floating around in the atmosphere. So because it's so dangerous, we have to ensure that there's none leaving the plant, absolutely zero. So what we do is we can actually put this HF back into the aluminium oxide electrolytic cell. So when we've got that molten cryolite aluminium solution, essentially, we can pump this back in and it will dissolve back into that molten solution. And so that's not a problem anymore. So it essentially just keeps recycling itself through the process. So that's not a big issue, okay? Sulfur dioxide can be reduced if we use very, very high quality graphite. So some graphite has sulfur in it, but if we use very good quality graphite, it won't have much sulfur in it, and then we can avoid that issue completely. And carbon dioxide is released by the oxidation of the carbon electrodes. So what happens is the carbon electrodes, the graphite, actually takes up oxygen and becomes carbon dioxide, and it is emitted. So if we use something that's not carbon, maybe that might help, but we haven't found anything that's cheap enough and also as hardy as graphite is. So this one's still an ongoing issue. Now, another huge problem is that aluminium refinement is an immensely energy intensive process. So I've heard of, aluminium factories which had to build power plants basically right next door because they just consume so much power. So it's an immensely energy intensive process. Some people have given aluminium the nickname solid electricity because it just takes so much electricity to give you pure aluminium that you might as well just call it electricity in solid form. Okay. So the refinement of aluminium is very energy intensive. What are the potential impacts of this high energy demand? Well, since the majority of electricity is produced through coal combustion, the large electrical demand means that CO2 emissions from aluminium refinement can be very, very big. And of course, this can contribute to human-induced climate change, okay? Other potential issues would be things like, the stability of the electricity grid. If you've got this huge energy demand and then all of a sudden maybe something breaks down and it all shuts down, that could damage your grid. There's all sorts of other energy infrastructure things that we're not considering yet, but just from a simple global warming perspective, it is a very significant problem, which is why the aluminium smelters of Australia took up very seriously against the carbon tax because they knew that it would greatly affect their business because they produce so much emissions, okay? Again, the refinement of aluminium is very energy intensive. I'm going to keep emphasizing this point because it is extremely bad in terms of energy usage. But despite this, aluminium is one of the most heavily utilized metals. Now, what properties of aluminium make it desirable? Okay, so why do we continue to use it even though we know that it consumes so much electricity? High tensile strength per weight is one of them. Even though this metal is low density, it has really good strength compared to significantly more dense metals. For the same amount of weight, you could get something that's much stronger compared to a more dense metal. So particularly for things that need low weight but really high strength metals, this makes aluminium really good. So for instance, jet fighters are mostly aluminium alloys because it's light and it's very, very strong. Now again, because of its low weight, it also has a really high conductivity per unit of weight. So for the same amount of weight, you could get a very, very good conductor compared to something that's heavier. So for the same weight of wire, aluminium is more conductive than copper. For the same weight of wire. Not necessarily the same size of wire, but the same weight. And it's also abundant. So it's one of the most abundant metals in the Earth's crust, which makes obviously good because if you've got a lot of it, it means you can do a lot with it. If you don't have a lot, then you're sort of limiting your applications. But these are the main ones: high strength, high electrical conductivity, and it's very, very abundant in the Earth's crust.